Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nabila binti Muhammad Rozi. My metric number is D0820101993. So today I would like to presenting about DC boost converter. So this is my group member Muhammad Husni, Muhammad Lukman, Nur Rashid, Nur Fahad, and Nur Nabila is me. The duration of the project is 37 days. So we already planned this project by doing in Gantt chart. So on November, we do online and offline research and manual calculation. And on December, we start doing simulation, but still we do some research to know better about this project.
Okay, Assalamualaikum. My name is Amirul Rashid. So today I will like to present my part, which is introduction. So, as you all know, DC-DC converter are a power electronic circuit that convert a DC voltage to a different DC voltage level, which is for our project we converted for voltage input, which is 6 volt, into a voltage output which is a 12 volt, which is we boost the value of voltage. And DC-DC converter also used as a basic switching converter, which is we can change the value that what we want from the input that we have been given. And then it also functions as an efficient alternative to the linear regulator. And it also used for power electronic switches like BJT, MOSFET, IGBT, JFET, and so on. So right now for our project, we are using a MOSFET IGBT. For the example, for boost DC-DC boost converter. And it also known as DC chopper, which is a same function, which is to convert it from input voltage, which is a smaller value of voltage, into the output voltage, which is the higher level of voltage. So I will pass to the next slide for the presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lukman bin Muhammad Ghazali. I'm going to present the methodology part of this project. There are two methods for this project, which is mathematical method and the simulation method. And for the mathematical method, the student must calculate and find the duty cycle, minimum value of inductance, maximum value of inductance, and the capacitance. And for the mode 1, which is open loop system, the student must find the differentiate value for inductors and current inductor. You also need to find the differentiate value for capacitance, and the student must find the state space which is using the matrix method. And this equation below is for the output that can get from the matrix method. And for mode 2, which is closed loop system, the student need to find the differential value of inductor as well as the differential value of the capacitance. And this is the state space, which also use the matrix method. And for the average state space for module 1 and module 2, this is basically the method that the student need to use to find the average value from both module 1 and module 2. And this is the output that kid can get from the module 1 and module 2. And this is the method that need to use to find the average state space. And the second method of this methodology is the simulation method. For this method, the students need to design a diagram block to simulate the circuit through simulation in MATLAB software. Firstly, the student need to design the block diagram, and the student also need to insert the calculated values to the specific component and set the input voltage to 0 when student done designing the block diagram and run the simulation. When after run the simulation, the student must record the output voltage value and record the output waveform pattern. That's all from me. Thank you.
Hello, Assalamualaikum everyone. My name is Muhammad Husni bin Abad Nais. And today I'll be presenting about the result for this control principle project. Okay, before we begin, we have two modes to begin with, which is mode 1 is open loop system and mode 2 is closed loop system. The difference between the both systems is the source that generating the signal. Okay, for the open loop system, we use pulse generator to generate the signal. Meanwhile, the closed loop system, which is the mode 2, is we are using the repeating sequence and the PID are used to generate the signal. Okay, as you can see here, the closed loop system is quite complex because the addition of the repeating sequence and the PID controller over here to supplying the signal to the MOSFET. Okay, next. Before we begin, we must find the parameter of the components. We need to find the value of duty cycle, inductor, capacitance. Okay, next, since this is boost system, we need to we need to enhance the input to the larger output. We start supplying the circuit at 6 volt and we must get the output at 12 volts. And initially we use the R for the 10 ohms and frequency at 20 kilohertz. Okay, we must find the duty cycle. The duty cycle we get over here is 50%, and inductor we get 125 microfarad, and max value is 156.2 microfarad. Okay, next for the capacitance value we get 151.51 microfarads. Okay, next is MATLAB parameter value. After we calculate all the parameter value for the component, we insert the value to the MATLAB. Over here we can see the input voltage is 6 volt, inductance is 156 microhends, and next the capacitor is 151.51 microfarad. And this is special for the closed loop system, which is the repeating sequence and the PID controller. Repeating sequence we can see over here is 0 and 0.00602, and the output value is 01. And the PID controller we can manipulate the output saturation over here and adjust the upper limit and lower limit. Okay, next. Okay, this is waveform of the open system and the closed loop system. They are quite similar, but there are slightly difference between them. The difference is between them is the settling time, which is open loop system is take shorter than the closed loop system. And you can see here the rise time the open loop system is quite shorter than the closed loop system. This is state space derived equation for the both system. And this is the diagram of the state space derived equation for the both system. And this is the reference state space for the mode 1 and mode 2, which is open loop and closed loop system. They are referenced together. And that's all from me, and Assalamualaikum and thank you. Next I will pass to the next presenter.
Okay, for the discussion, all the specifications stated previously have been met by this boost converter design. The output 12 volt have been proved by doing the simulation in MATLAB. The diagram consists of inductor, a semiconductor switch, MOSFET, a diode and capacitor. We also do the validation for parameter model mode 1 and mode 2. Lastly, we are able to analyze transient responses, which is rise time, setting time, and overshoot. By looking at the waveform, the graph that we got is under damped. For this project, under damped is the most stable system compared from other system. From the previous slide, which is result, we can see the graph like this, which is under damped. For boost, we got under damped, and from this to this is overshoot, settling time from this, and the rise time. Thank you.
My name is Nur Farha Atik Binti Jaafar. So I will present for the conclusion. From this project, we can conclude that capacitors and magnetic devices are important elements of switching converters because ideally they do not consume power. Besides, it is the resistive elements as well as the linear mode semiconductor device. Okay, semiconductor is in switch mode, however, dissipate comparatively low power in either states, on and off. Hence, capacitive and inductive elements as well as switch mode semiconductor devices are available for synthesis of high efficiency converters. Okay, besides the report by summarizing the important benefits from the carried works and provide a good discussion and guidance on the design aspect of boost DC to DC converters. That's all from our group. Thank you.